All right, here we go. Draw the location of the angle, determine the quadrant, and give the sign, whether it's positive or negative, of the trig function in that quadrant. Then find the reference angle to see which triangle below you would use to find the value. So let's look at the triangles below first off. And we have two special right triangles that you may recall from back in geometry. And one's going to be a 45, 45, 90 right triangle, where the two smaller angles are both 45 degrees, the right angle being 90 degrees. And when we have this, maybe a little bit clearer way to write this would be that the base of it, which we're going to have along the x-axis all the time, if that's x, then the y value, the other side, that's also going to be a value of x, whatever that length is here. It's the same as the height because they're both 45, 45 angles, meaning it's isosceles. And then the hypotenuse is going to be x, so let's erase 1, let's clear that up a little bit, which is going to then be whatever x is times the square root of 2. And that'll be the length of our radius. We're going to deal with it a lot of times where radius is just 1, and so then we'll divide both legs by the square root of 2 to get back to those lengths. Over here, we also have a 30, 60, 90, or yeah, 30, 60, 90 right triangle. 30 degrees, 60 degrees, and 90 degrees. And here we had that x value, that base, is x, and then the longer leg is times the square root of 3, and the hypotenuse, I'm going to get rid of 1 here, it's 2 times x. Whatever the length of that x value here is for this shorter leg, it's 2 times that for the hypotenuse, and times the square root of 3 of the short leg to get to our long leg, the 30, 60, 90 right triangle. A lot of times we'll keep the hypotenuse really as 1, because that's going to be our radius of 1. So we would divide that by 2 to get to our x value, and divide it by 2, and then multiply it by the square root of 3 to get to that longer leg. And we also have in here, notice the radian values. Instead of degrees, we could have pi divided by 4. That's equivalent to 45 degrees for both angles here on the 45, 45, 90. Or for the 30-degree angle, that's pi divided by 6. And for the 60-degree angle, well, it's twice that, so it's pi divided by 3. Okay, knowing all that, let's come back and see if we can get kind of a better grasp on what this question is asking. So starting off, let's sketch it, because draw the location of the angle. So let's start by drawing it. And actually, we'll make it a little bigger. We're going to have 135 degrees. We're given this one in degrees. So that's going to be up past 90, not to 180, but 135 degrees up to right around there. And that leaves us, how short of 180 are we? Well, we're 45 degrees short. That's right at our alpha value or theta value, whichever one you're using right there. That is going to be 45 degrees. Our reference angle there is 45 degrees. So this is in, determine the quadrant. It is in, so 45 degrees is our, our theta is 135. Let me change the way I have that. Our theta is 135 degrees, meaning our alpha, oops, I wrote that backwards. Our alpha is going to be 45 degrees, our reference angle. Sorry about the confusion there. Now, determine the quadrant. So this is in quadrant 2. And give the sign of the trig function. So we have sine, and sine is positive. So sine is going to be positive. It'll be positive. Now let's go ahead and work our way through. So if the radius is 1, or actually we're just dealing with sine. So remember, sine is equal to opposite over hypotenuse of our angle alpha right here. And so if we had an angle, there's our 45, 45, 90 right triangle. So this is going to be 1. This is 1 over the square root of 2, and this is 1 over the square root of 2. So what is the sine of 135 degrees, well, the sign's going to be opposite, 1 over the square root of 2. Oops, let's get that all up in the numerator. 1 over the square root of 2 divided by, what's our hypotenuse? Our hypotenuse is 1. So really this is just 1 over the square root of 2. We've got to clean that up a little bit. Rationalize our denominator. So we're going to multiply both the top and the bottom by the square root of 2. So what is 1 over the square root of 2 times the square root of 2 over the square root of 2? That's going to give us square root of 2 divided by 2. And again, that's positive because the sign in the second quadrant is positive. There's our value. All right, seeing that, please pause the video and try the next few without just walking through it. So really do pause and try those on your own now. All right, so hoping you have in fact paused it and are coming back after trying them on your own. So here, let's sketch the angle, draw the location. So we're going to have negative 45 degrees. So here we are. Negative 45 degrees is always, remember we're using the x-axis to find our alpha or our theta, and for this one it'll be right in here. There's theta, 45 degrees for our triangle. So we're going to have a 45, 45, 90 right triangle. Actually, we already got the picture over there. We don't need to do that again. Hypotenuse of 1, our legs are going to be 1 divided by the square root of 2 and 1 divided by the square root of 2. And remember, we're in quadrant 4, and in quadrant 4, it's cosine that is positive. So our answer here should be positive, and you want to have a negative 1 1/2. You could do that there to help yourself remember which one it was going to be. So cosine, though, cosine of alpha, or of theta rather, is adjacent over hypotenuse, which is going to be 1 divided by the square root of 2 over the hypotenuse of 1. And so really you don't need to divide by that 1. It's just going to be 1 over the square root of 2. Rationalize our denominator, and we get the square root of 2 over 2. And again, cosine is positive here, which makes sense because this is x value here is positive. Divided by our hypotenuse, we're at a positive value. All right, so C, and I hope you've tried this one on your own already. See, we've got 210 degrees, so if we're graphing this, we've gone past 180, and 180, and then another 30 degrees. So our reference angle here, our theta is 210, our alpha, our reference angle, is going to be 30 degrees. 30-degree reference angle. And so that's going to give us the 30, 60, 90 right triangle. So if we have a 30, 60, 90 right triangle, the hypotenuse, the radius has always been 1 for us, so the short leg is half of that. The short leg is going to be 1/2, and the long leg is going to be 1/2 times the square root of 3. Now we've got all of our pieces. Let's see what we got going. And so this is going to be sine. Remember sine? Actually, let's also write down we're in quadrant 3, and only tangent is positive over here. So we're probably going to be, we're using sine, so we're going to end up with something negative, and that'll make sense here in just a second. So sine of, sine is equal to opposite over hypotenuse. Our opposite is, so sine is going to be 1/2, and kind of think, hey, this is going down below the y value, so you could even think of it as negative 1/2. Negative 1/2 over 1, hey, that reduces down to negative 1/2, and we are set. D, and once again, hope you've paused this. Here's our first one with radians. We've got the cosine of 3 pi divided by 4. So sketch our graph. Box these all up as well. sketching our graph, we've got 3 pi over 4. And remember that pi would be over to 180 degrees, but it's 3/4. So half of pi gets us to here, and then we're going another fourth. We've got ourselves a reference angle of pi over 4. Sorry, pi reference of pi over 4, or 45 degrees if you want to translate it kind of that way. So we've got, we're in quadrant 2. Quadrant 2 sine is going to be positive, so our answer better end up being negative because it's cosine. And so the cosine is going to be, remember, adjacent over hypotenuse. And let's go ahead and get our side lengths of this triangle. If the hypotenuse is 1, on the 45, 45, 90 right triangle, we're going from the hypotenuse, we're going to divide by the square root of 2. So 1 over the square root of 2. 1 over the square root of 2. And the x value, the cosine, that's going to be negative because we're going to the left here. And we've already rationalized that denominator a few times. That's going to end up being negative square root of 2 over 2. All right, a couple more here. We've got, or actually, you know what, this video is getting kind of long. Let's pause there. Really do please try, actually G and H you'll need a calculator on. So we'll go ahead and finish up these next two. But please pause, try them again if you haven't yet. Do try to be able to do them on your own. Here we are. We've got sine of negative 2/3, so we're going to go negative around the circle, and negative 2/3 gets us to, well, that's pi would be right here, but we're going negative 2/3, so kind of cut this up into thirds. You can think about it that way. -1, -2. There's our reference angle, or sorry, there's our theta and our reference angle then, or we're going always to the x-axis. So here's our reference angle. That's going to be 60 degrees, or in terms of pi, that'll be pi over 3. Pi over 3. Okay, so continuing on, we've got sine. This is in quadrant 3. Quadrant 3. So tangent is the only one that's positive. We've got sine though. So sine, remember, is opposite over hypotenuse. So our hypotenuse, keeping it as 1. And you can have it be other numbers because it's a ratio. It actually doesn't make a huge difference as long as you're just following your pattern here. But if we have the hypotenuse of 2, and we want to get down to the shorter leg, it's half. So 1/2 and -1/2, if you want to think it that way. It's left of the x-axis. And our y value then is 1/2 times the square root of 3. So square root of 3 divided by 2. And that's also negative because it's below the x-axis. All right, so we have sine is going to be, what's our opposite side? Opposite side is -3 square root of 3 over 2, all divided by 1, which just gives us negative root 3 over 2. There's our answer. And last one without needing a calculator. We've got the cosine of 11 pi divided by 6. And so here we go. That's almost 2 pi. Not quite, but almost 2 pi. It's gone around all the way until there's just 1/6 pi remaining. There's our triangle. And so that's going to be a reference angle. Our alpha right here is going to be 30 degrees. Or since it's in radians, let's keep it as our reference angle being pi over 6. Okay, so we've got our triangle here with a hypotenuse of 1, our short leg being 1/2, and our long leg being root 3 over 2. And if you want to think of the short leg here, the y value being negative because it's going below the x-axis, that'd be a good thing to kind of keep thinking about. Our quadrant, we're in quadrant 4. Oops. Quadrant 4, where cosine is positive. So we're going to end up with a positive value, which makes sense because this is a positive x value. And so cosine is equal to adjacent over hypotenuse. Our adjacent is the square root of 3 over 2, all divided by the hypotenuse of 1, which just gives us root 3 over 2. All right, hope that all helps. And then here in the next video, we'll set up those same proportions, though we'll need to use our calculators to really solve them. All right.